Every day, contaminants enter facilities, unseen and unnoticed. A person carrying electrostatically charged contaminants walks into a high-precision manufacturing space, unknowingly introducing risk. Even during the gowning process, these electrostatically charged contaminants cling to surfaces and clothing, remaining active and mobile. As the person moves through the clean room, particles disperse into the air, compromising the clean environment. Parts entering automated production are already compromised by static-charged contaminants. Manual handling in clean rooms allows even more contamination from unneutralized surfaces and static charge. Even clean transfer rooms become carriers of contamination without proper ionization controls. Contaminants cling to packaging materials, continuing the chain of contamination beyond production. Contaminated products are shipped, reaching end users with compromised safety and performance. What started as an invisible problem now becomes a visible threat: medical device contamination at the point of use. Now let's see the difference. With ionization protocols in place, even a contaminated individual entering the gowning room begins the process of charge neutralization. Electrostatic charges are eliminated, reducing the spread of contaminants and keeping the clean room truly clean. Critical parts are neutralized during production, ensuring they remain clean and uncontaminated throughout the process. Controlled environments maintain clean conditions when ionization is strategically deployed. Ionized transfer rooms act as protective buffers, preventing recontamination at each touchpoint. Ionization prevents contamination from clinging to packaging materials, ensuring that only clean, static-free components make it to shipping, ensuring safety and compliance for end users. Ionization doesn't just control static, it removes the pathway for contamination, because in precision ultra-clean manufacturing, what you can't see can hurt you. Make it clean, maximize yield, keep it safe with Simco-Ion.